First things first in this question, we don't know what p is, so we need to calculate it, and it must be when we add them together that we get the value of 1. So I can do 1/12 plus 1/4. Which gives me a third, and I can write down that a third plus 4p is equal to 1. That means that 4p is equal to 2/3. So p is 2/12, which is 1/6. And now I'm just going to replace this by 1/6, and this one would actually be a half, 3/6. We're told that two values of x are chosen at random. Determine the probability that their product, that means when you times them together, is greater than their sum. That means when you add them together. So I suppose we could look at the possibilities. We've got 0 and 1, 0 and 2, etc. Now the product of these is going to be 0, and the sum is going to be more than that. So actually we can rule all of these out. That just leaves, so anything with 0 in fact, isn't going to work. We could try 1 and 2 and 1 and 3, but actually for these as well, the sum's going to be bigger than the product. This leaves us with 2 and 3. The sum is 5, but the product is 6, so that one works. Or 3 and 2. Actually, you could do it. You could get it the other way around. You need to include that. 2 and 2 doesn't work because the product is the same as the sum. So this just leaves us 3 and 3 as the other option. Those are all the different things you could get. So the product is greater than the sum. We just need to then work out the probability of this. Right, the probability of getting 2 then a 3. Well, you multiply the probabilities. It's going to be 1/6 times a half. And then for 3 and 2, it's just going to be a half times a 6. It's actually going to be the same thing. And for 3 and 3, it's going to be a half times a half. So these are like ands, 2 and 3. So you times it, 3 and 2, so you times it. But within this, it's this, or and you add these together. It's like you've got a tree diagram going on, and this is sort of getting 2 and then getting 3. So we're interested in that one. And this one's getting 3. And this one's getting 2 and 3, and of course there's like getting 1 and 0, but we don't really care about those. It's these ones that we're interested in. So we're just timesing along the tree diagram. We just don't draw that tree diagram, just get on with it, but you can if you like. And then we need to figure out this answer. So actually I'm going to do this without a calculator. It's going to be 1/12 plus 1/12 plus a quarter, which is actually 3/12. So overall, I'm going to get 5/12. That is my final answer. For the final part, we're told a random variable y. So this is actually unrelated. It's just a different variable. It takes n values. We don't know how many. Each of which is equally likely. That's really important. Two values, y1 and y2, of y are chosen at random. And it's given that y1 equals y2 is 0.02. Find the probability that y1 is greater than y2. Okay, let's just think about this. So we have some sort of distribution, n lots, and I'm actually just drawn lines going up. They're equally likely. Here we go. And then I'm picking two values. Actually, this is just a distribution of y. I think I've done that. Okay, I'm just trying to illustrate the main idea. So the probability of me getting the same value is 0.02. What I'm trying to get at with this, actually, is that means the probability that y1 is not equal to y2 is going to be 0.98, because it's just 1 minus that. But there's nothing special about this side and this side. Let's say that this is me getting y1 less than, this is me getting y1 is more than. So actually, this is going to be a symmetrical distribution. So it must be that the probability that y1 is greater than y2 is just going to be this divided by 2. It's going to be 0.49. So this question is just kind of sort of testing your understanding of the symmetry of the problem. Because it's equal to 0.0, well, when it's equal, it's 0.02, so when it's not equal, it's 0.98. It's the same either side because they're all equally likely. So I divide by 2, it's 0.49 either side, and that's going to be my answer.